Welcome to this tutorial, and we will focus here just on some programming examples, specifically still relating to this introductory sort of phase that we are in with the ATmega 328P. So how we are going to go about is I'm going to show you a visual example, and then based on what you see, this is what we have to write the program about. So just observe what is happening here. We notice that there's some LEDs, and we notice there's a button. And then we notice this relationship between when the button is pressed versus when the button is not pressed, and how that affects the sequence that you see on the LEDs. So let's play it again, and then we just go slowly. So you see, sorry, there my. So initially, you notice that the lights, the LEDs. So when the whole thing sort of comes to life, we have this green LED, and the red LED is sort of lit. Well, not sort of lit. It's lit. It goes on. Then, as we progress, you notice then the next thing that happens is the blue LED goes on, and then so the blue LED and the green LED then remains on. Now notice that all of this still happens while the button has not been pushed. So when the button is not pressed, all of this is as we currently see it, and then you see green remains static, the green LED remains static, and the blue LED flashes until the button is pressed. So here you can see this is now in slow-mo, but there's about a half a second on, half a second off time delay, roughly on that delay, what we can more or less also see. The moment the button is pressed, now you can see something else happens. The blue LED switches off, the red LED switches on, and now the green LED flickers. You can notice that is happening here until I release the button again, and then the blue LED flashes. Then you press the LED, and you press the button, and then we have the red LED. So you can see basically, let me just play it again, and then you can see if the button is pressed, we have the red LED that goes on, and then, so sorry, the green LED doesn't flash. It's when you press the button, the red LED goes on, all the others go off. When you release the button, the green LED is on, and the blue LED is off. So what do you notice? And let's just write down a basic sequence. So firstly, here when we have power on, the first thing that happens that we saw was that the green LED and the red LED goes on, and then after that, so the first thing that we see is the green LED and the red LED is on. Then the second thing we notice is after that the red LED goes off, and you have the green and the blue LED that is on, but the blue LED flickers. Come on, why isn't it? There we go. So here you can see red and green is on, and then it's in the cycle where the blue LED flickers until the button is pressed. So basically, so this is initially we are here, and then the second thing that happens is basically we need to start looking at that switch. So because we notice that when the switch is pressed, or when the button is pressed, it has one course of action. but when the button is not pressed, there's another course of action. So let's start by asking the question here, is the button pressed? And this is a question, so here we perform a test, and with the test there's one of two outcomes. There's a yes, it is pressed, or no, it's not pressed. So now we will proceed. If it's not pressed, we notice then that you have the green LED is on and the blue LED a flicker. Basically it does this flip-flop thing. It just flickers. Well, it's not really flip-flop. Flip-flop would imply that there's two, so the blue LED flashes. Okay, so that's the action that we have to take at this point. And notice also that the red LED, so as part of this, the red LED is off. Okay, so this is basically on repeat, which means this will just run continuously. When I do press the button, what do we notice happens? The blue LED as well as the green LED is off, and the red LED is on. Okay, so we can get a little, we'll get specific later about when we talk about the flash, because remember, when there's a flash it means there's going to be a delay. But I mean, that's at this point the specific time delay, the actual time of the time delay at this stage is irrelevant. We're just trying to see what are the sort of the sequence of events that takes place, and then this also basically continues indefinitely, and that is the process that we will go through. So we can see here we have our basic logical steps, and we actually in the process formulated our a flow chart which we can base our program on. So before we write our program, let me ask the question, what do we always do first in our programs? Now, I know you're new to Atmel, but you know that there's a few things we always do. And so initially we have to make sure that we have all of our libraries included. So always make sure that all your hash includes are in place, and your definitions. Make sure all of this also is in place. Your defines, your includes, all of that. Then from there is the direction of the ports that we need to set up to make sure our ports function according to the direction that we've declared it in. And then we will launch into our main program, and then in the main typically is where we will then declare variables, and then actually have the functional code. That's to say the code that will execute the desired outcomes. All right. So now let's look at the code. So as I've said, we have our hash defines, hash includes, and just notice here, typically when you work with the Arduino straight up here, you use 16 million UL, but on Proteus, for simulation purposes, we just slow it down to this, because then you actually get correct and corresponding time delays. Otherwise, it's way too fast, and 1,000 millisecond delay is not 1,000 millisecond delay. It is 16 times shorter. So for Proteus purposes, we use 1 million, but for in real life, when you actually program your Arduino, your AVR, your Atmega 328, you will use 16 million for that. Then I've just assigned some names to my actual ports or pins on ports. So port B pin 0 is test. I just called it test. Port B pin 1 is green. Port B pin 2 is red. And the test is the blue LED. Now the reason I called it test is because there's a few other ideas I have for this. So this LED actually has the name test, but for now just know that this is the blue LED. Then in my main program, so sorry, in our sequence here, I said we declare the direction of the ports, and then we have the main. But remember, you actually always you put the direction, the declaration of the ports in the main. So what I mean to say is the main part is basically going to be the part that we want to sort of execute continuously. So first up, we set the direction of the ports. So port B is going to function as an output, and port C, because this is where we have the button, functions as an input. And then we have that initial state where we switch the green and the red LED on. So here you can see this is to make sure that these two LEDs are turned on. Then there's a 1 second delay, and then you can see I'm going to turn them off. So this is the code that we use for that, is port B or equal, and then here's our instruction that we have introduced in other lectures. So this is how you can manipulate that specific bit on port B separately without affecting any other bits. Now there are other ways of doing this, which I have shown in previous lectures, but I'm just sticking to this method now because it's quick and easy. And then so this is to turn those outputs on, and to turn those outputs off, because it's forward biased LEDs, it means a 1 switches them on and a 0 switches them off. And so here I have port B now that I say and equal with your tilde sign. This is to basically perform the AND function now on it, and to then invert the output, and thus giving you your off. So once again, you can now turn these specific bits off without sorry, this is not AND, this is invert. Forgive me for misspeaking, but this is the process then that you have to use when you want to turn it off. You cannot just say a 0 ORed with 0 here. Ultimately you'll find that on the port, and I think I've explained it in those specific in other lectures, the port then doesn't actually turn off, because a 1 ORed with a 0 will always be 1. So to try and manipulate it back to a 0, you need to incorporate a sort of like an AND function, the idea of an AND. But in any case, that is explained elsewhere. Then in my continuous loop, for the continuous loop, we now have to do the following. Now remember, here we had this big decision that we were making when we to determine whether or not the button is pressed. And so how we do it in code, or well, how I chose to do it, remember there's always one way, always more than one way when you write code. This is just the effective way I found. Now I have in a continuous while loop, this is basically, so this while that you now see here basically is this whole section that's going to continuously run. Now we need to do this. How do we test for that button? So I'm saying while pin C and with 0x01 is equal to 0. So let's just break this down. Let's just take this and break it down. So pin C, what does that mean? We know when we say pin C, we know that what's going to happen is I am reading the whole of port C. So pin C is going to read the whole port C. Then why do I do this? Why I say AND with 0x01? It's very simple. Let's go to our circuit diagram. Now here's port C. Now you notice that the button here is connected to my least significant bit on port C. So it's connected to port C pin 0. Now also notice that as it is connected, what happens is when a button, why does it keep doing that? When a button is not pressed, you basically have a 0 on the port. So here you can see when the button is not pressed, this is 0 because I have this resistor to ground that will basically just pull this output or this input low. But the moment you press this button, the current will now flow through the button and not through the resistor but through the microcontroller to ground. So this will then raise this to a 1. So when the button is as it is here, when it's not pressed, then the output of the button basically is 0, and when it's pressed, the output of that button is a 1. So now we can come back here. Now why do I AND it with 0x01? Well, remember in binary, this is the value. Okay, and this is basically the least significant bit. This bit over here is my least significant bit, and this is on port C where the actual button is connected. So now remember, I have read port C. So port C at this stage has an unknown value, 8 bits unknown. Okay, it could be anything. Now I AND that with this value, and I'm saying while the result of this is 0, do this. In other words, if I take this, so let's say I'm reading port C and I haven't pressed the button. That means I know that this is going to be 0. Now a 0, and so if I have this, so let's say I've got the unknown value x, but there's two scenarios. So this could either be a 0, so let's say in the first scenario it's a 0, but I'm ANDing that with this value. Now I can see the result. If I logical AND this, my result here is going to be 0, and which means that the button is not pressed. So this is exactly what I'm doing in this statement. But what happens when this now changes and it becomes a 1? Then it's 1 and with 1, and then the result is 1. Now I know a 1 then means that the button is pressed. And so that's how I can distinguish between when a button is pressed and when it's not pressed. So here, this is basically going to help me find out when it's not pressed, because I'm testing for a 0. And if it's not pressed, we said what we do is we turn the green LED on, we turn the red LED off. So green is on, red is off, and then blue, this is the blue one, the blue one comes on, but then we flicker, there's a flicker on the blue. So here you can see I've got 400 milliseconds, then I'll turn the blue one off. So here I've got blue off, 400 milliseconds, run through the cycle again and just double check and see, is the button pressed or not pressed? Then make sure that green is on, red is off, and go through the cycle. And so basically this is just how we run through what we have discussed and sort of written down over here. Now should it happen that you now press a button and this state is to be found, then this is not going to be 0. Then it's going to be 1, which means this whole section is not going to be executed. So then it's just going to, the it will jump to this portion of the code where it turns the red LED on and the green LED is turned off. The blue LED will, you can also explicitly, I suppose, turn it off at this point, but I haven't now explicitly expressed that in code. So here you can see this is what happens when the button is pressed, because upon doing this test it found that it's equal to a 1 and not a 0, because remember, this portion of code will only execute when this is indeed true and when this test is found to be a 0. When it performs this test and the result is a 1, it's going to execute this part of the code. So, oh, look at that. So that is the program then for what we have noticed in that first section. So what I now want you to go and do, and then you obviously can you can ask me questions if you do this and you struggle, is you know our support group, and you contact me on that support group and you ask me questions specifically relating to this. But I want you to go and practice this whole process. Go through it by yourself. Remember, you have the solution, so you've got nothing to lose. Go and try this, and when you get stuck, then you refer to what you know I have done, and then you can try and see if you can correct. If you can't self-correct, then please contact me, get on the support group, and then we can sort of address any misunderstandings or issues that you have. We can then address it there. So now I just want to show you now one minor adjustment we can do. Now this is something new. So here you can see this was the instruction that we used to perform the test. Now you can see what I just did here says, and so the rest of the code is exactly the same. All I did is I'm now just substituting this. It's just this line that I want you to focus on now, that I want to show you that I'm making a minor adjustment to make life a little bit easier. Because here, so I'm saying hash define 1. Now you can give this any name you want. I just called it 1 because it was the first condition. Because as we continue, you'll see there's a 2 and a 3. And this is just conditions or tests. So test number 1 is this test, where I check where I read port C and I AND it with, now once again you can see here I wrote this difference. So, but this is exactly the same as saying 0x01. Because here you know button has been declared to port C pin 0, and so I'm just saying when button is a 1. So this is basically exactly the same as saying 0x01. Another way of saying it is 1 left shift button. This is just to this is how you would typically have turned an output high or low, but we also can use it in a test. And all I've done is I've now sort of just defined this whole instruction and sort of assigned it to a term, and the term I decided is called 1. You can give that term any name. And so now instead of saying while pin C and 0x01, you say while 1 is equal to 0, because then it will look at this, but it actually does all of this, which is exactly the same as what we did here. So that's just a nice way to sort of condense your code and sort of just make it easy for you to, if you have specific tests you want to do the whole time or procedures, you can define those instructions and assign them to terms and then just use that. And so that's a minor adjustment, but that's, I think this is what we could call a top tip when it comes to programming. So yes, so now in our next example, what we are going to do is the similar process, and that will be in a separate session. So for now I want you to first go back and try what we've done in this session, and then we've got something else happening in the next session, which we will then get into.